today I'm going to go over two position linkage synthesis using poles and rotation angles. This is a method developed by Ronald Zimmerman in a way to design 4-bar mechanisms in a graphical method instead of having to do analytical calculations or guessing and checking to make sure your mechanism actually works. So the whole goal is to design a 4-bar mechanism where your only constraints are two positions. So you have a starting position and an end position for a specific link. So it's just an overview of 4-bar linkages. You have a coupler, which is the link that you intend to move from position 1 to position 2. It's the important piece. Connected to that are connector links, which simply connect the coupler to a base plate or some kind of foundation. Now, getting into the method by Zimmerman, there's a few pieces of nomenclature that you need to know. First of all, a rotation angle. This is the angle through which the rigid body, the coupler in this case, rotates from one specified position to another. So as it moves from one position to the next, it's going to essentially rotate around some center location by this rotation angle phi. Some other pieces of nomenclature that you're going to need to know in this are a moving pivot. This is essentially the pivot location on the coupler that connects the connecting link to the coupler. The reason it's called a moving pivot is because the two links pivot from one to another, and it can also move because the coupler is moving. Your fixed pivot is going to be the bottom connection of the connector link to whatever base foundation you have. Moving from there, the pole, in which I mentioned that the coupler is going to rotate around some center location, that is the pole. It's going to rotate around the pole by a rotation angle phi. Now, when we get into a little bit further, there'll be a line of moving pivot and line of fixed pivot. These are simply lines where you can arbitrarily or analytically select the position that you want to locate these pivots along. So when we get into a little bit further, you'll see where these lines come in. So for an example, we want to move this bar from position 1 to position 2, which rotates through this rotation angle phi 1, 2. The subscript is important to mention that the angle is going from position 1 to position 2. For a 2-position example, it's not necessary to actually have this subscript, but when we move into more 3-position, 4-position, 5 positions where you have additional constraints, the subscripts become very important. So the goal is to design a 4-bar linkage mechanism that can move this bar from position 1 to position 2, the coupler, I should say. All right, so the step 1 is to simply draw the two positions that you want the coupler to move through. And then essentially each line represents the actual coupler in each position. The endpoints are where the connecting links are going to attach to, so that's an important thing to do. So the first thing you want to do is locate the pole. Now the pole is located at the intersection of the perpendicular bisectors of the two positions. So you simply draw a connecting line from the left end of position 1 to the left end of position 2, and similarly for the right end of each position. And then you go to the intersecting bisector of that line, and then wherever these two lines intersect is going to be your pole. Now, if you are moving from position 1 to position 2 and they don't rotate through an angle, whereas position 1 and position 2 are parallel to each other, these lines will never intersect, and that'll be an example for another day. So these are specific examples where there is some sort of rotation angle involved. So now we want to locate where the pivot line or the pivot locations are going to be. So what you can do here is you draw two pairs of lines that represent a moving pivot and a fixed pivot, and they have to be separated by half the rotation angle. This will be more apparent when I do an example later on in Creo. But the step is to draw two sets of two lines from the pole that are separated by this half of this rotation angle. And they could be in any arbitrary position, and you'll see that it'll work out either way. What these lines do, though, is they provide you free choices for selecting locations for your fixed and moving pivots. So this can play out really well if you already have, like, for example, your foundation or your base plate that the two connecting links are going to connect to. but you don't know where you want to place the holes. These lines can help you select those places. Now, I would like to note that these moving pivot lines can be directly connected to the link. For instance, like if these are the two end pieces of our coupler, why wouldn't you just connect those ending points be the moving pivots? So if that is the case and you want to do that, that would be your moving pivot selection, which would make this blue perpendicular bisector your line of fixed pivot, so that you can essentially select any place along these blue lines to be your fixed pivots. I'll show another example of that as well at the end of this. So now that you have your moving and fixed pivot lines, you can draw your connecting links in any arbitrary position you want. Note that these aren't connected, and we'll see what we can do to fix it at the end. But essentially, this gives you the freedom to choose and easily see any options that are available to you, for instance. So now that you have these selections, we're going to now connect the moving pivot locations to the actual coupler link by this rigid mechanism. So now, instead of just being a link that's a straight bar, for example, now you have this almost like a trapezoidal setup or a quadrilateral setup where these dotted lines are rigidly affixed to your coupler. And then what you can do is then when you rotate around these fixed pivot lines, you can see it begins to move from position 1 to position 2. However, if you connected your line of moving pivots directly to your coupler, then this step is actually unnecessary. So just an example, this is walking through the exact thing. Our original link was just this one bar, and we want to move from position 1 to position 2. We selected our fixed and moving pivots, and our connecting links were drawn, and then you connect this rigid body. And then as you can see, as it rotates, it can reach position 2. Now, I did mention you can connect the connecting links directly to your coupler, and as you can see, this is a little bit simpler. But for example, it can go from point 1 to point 2, and it just rotates. Personally, I don't see why, or I haven't seen a situation where this approach, but this is just an arbitrary example, to be honest, to show you how the method works in this case. Most likely, most of the time, you're going to have something that ends up like this, where you don't have that additional geometry for your coupler required to do so. So now that we've kind of gone through the slides, probably kind of just ignored some of them, but we're going to actually do an example. So I'm going to begin in Creo. If you guys haven't used Creo, SolidWorks could probably do the same thing, but I use Creo, so that's what this is going to be in. So we're going to name this some arbitrary thing, so 2 position, and this is going to be an assembly because it's going to have to move. It's going to be moved, and it's going to have multiple parts. So we'll name this 2 position. For example, for proper names, you can't have spaces, so hyphen or an underscore is usually acceptable. And this brings you into the application, the assembly modeling tab. So the first things I always do is I make sure I have my filters. So my model tree is very important when it comes to assemblies and maintaining assemblies, is you want to have a clean, efficient tree over here. And what I did just there is essentially open the filter so that it displays all my datum planes, because you need these for assembling different components. Another thing, I usually get rid of some of these extra overlays because they just cloud the environment. And then the last thing I do to initialize all my assemblies is I set up a skeleton model. Now you can look up skeleton models, and I'll actually be putting out a video series and tutorials in Creo, but for layman's terms, this is essentially where I place all my datum planes, just so I can close this little tree, and then all of this will be just parts. Obviously, it's got the top datum planes, but this is where I place any datum planes that I want to, and this will actually be where I do all my sketches for the 2 positions and whatnot. So the first thing you can do is, what you want to do is you want to activate this so we can start doing things in here. So first, let's draw our 2 positions in a sketch. Let's go to the sketch view, and let's say we want to make this bar go from, if it would actually draw the damn bar, this 2 position. I hate their arbitrary sizing. It's 100 inches, but let's let's get this down to like, say, 5 inches. And this is an arbitrary example, so let's do like 7 just to get it a little smaller. And of course it didn't work. All right, so most of you don't know, but I don't use my arms, so I have to have this on-screen keyboard and my mouse, and for some reason this application is not liking it when my keyboard is on another screen, which sucks, but all right, let's zoom in a little bit. Actually, matter of fact, I want to change some of these settings. Let's change your color so it's not as visible. All right. All right, so just to draw my links, I want to control the length of this. So what you can do is simply click the dimension, click on a link, and then middle click. I don't have a middle click dwell option, so I got to do this thing special. So I'm going to make her, of course she's not going to go 4 inches long. Wait a second. Why are you... Okay. This is now going to be a pain. Oh. All right. Cancel the sketch. Let's do this again. All right. All right, so the first thing we're going to do is we're going to set up a sketch. All right, so first thing we want to do is set up a sketch in our skeleton model that is going to represent our 2 positions. So we're going to rotate like this, and now these dimensions that it automatically gives you, they can work, but I like to control the length of my links directly. So we're going to make this coupler 4 inches long because it's a small part. It doesn't have to be 83 inches from the origin, so let's just say 4 inches from the origin. And then we can zoom to fit. And then this angle is right now referencing the vertical axis or vertical plane, but I tend to like to have it reference the horizontal plane so you can know exactly how off the horizontal it is. So let's quickly get this dimension against these 2 planes. Click Control too many times. Boom. And it's at 24.93, but I'm OCD, so let's do an even 25. All right, so this represents the first position. So now you can either copy and paste, which is the easiest thing to do, because this allows you to place it wherever you want. You can rotate it however you want. For instance, let's rotate 20 degrees in the opposite direction because it's going to be like that. All right, so that's 20 degrees, and then where are we going to put it? Let's go right here. Why not? Boom. So now you have your 2 positions. Boom. Let's turn these planes off so that you can just see the positions. So one thing I also like to do in this model tree, which isn't necessary for this video, but I like to name everything so I know exactly what it represents without having to click on it and see what it highlights. Since this represents positions, it's going to be named Position Sketch. All right, so step 2, if I go back to the PowerPoint. So we did step 1, you drew your 2 positions. So now we want to go to step 2, which is locate the pole. Now, the pole location is another sketch we can use. So we want to sketch off the front data plane, same data plane our 2 positions are. And I like to play in construction mode here because you can draw all your lines, yet they don't show up, which is nice because once you get all these sketches, you're going to see that there's going to be a lot of lines. So you want to connect these 2 endpoints. In Creo 5, which I'm using here, it automatically selects references for you. That's why I didn't have to declare these lines as references. It just knew that I wanted to, which is pretty neat. But anyway, so now we have our 2 connectors, and now we want bisectors. Because it's a sketch, you need some physical object in the sketch that's not a construction line in order for it to be saved. So we're going to draw this nice little line through here, and the same thing. We're going to draw a perpendicular line until they intersect. And then we can trim this extension and just throw a point in there for safety. But now you've located your pole. And because I'm going to stick with my naming convention, it's going to be the pole. So now we know that these two links rotate from this position to this position about this pole location here. So if you wanted to think about it, if we don't add any more position constraints, this would freely rotate around this pole if the mechanism allowed. All right, so it can freely rotate around this pole. So now that we've located our pole, we need to draw our pivot lines to locate our pivot lines. So we're going to do this in a sketch again. Bring up my keyboard. So this angle between these two, let's just remember what this is. Because the pivot lines need to be separated by half of this angle. And of course it's not going to do it because they're not physical lines in the thing. So we're going to go here, because I'm lazy, just go to our earlier sketch. 20 angles, yeah, all right. I don't know why I forgot that. It wasn't that long ago. So we needed to draw our pivot lines with it separated by 10 degrees. Now, if you were to just draw simply, like say your moving pivot line wanted to connect here, well, your fixed pivot line is already drawn because this is half your rotation angle, which makes sense because it's half the bisector. It's like if this rotates from here to here by 20, if it only rotates here by 10. But what you can do, if you wanted a little bit more freedom, you draw one line, you draw your next line. They're separated by 10 degrees. And then you can literally, where did my keyboard go? My clicker. People with hands and mouse makes this a little easier. I need this little extra thing since I can't use my hands. Why aren't you? All right, select this. I want to lock this dimension because I'm going to go and try and freely drag this around, and I want this to stay locked. So now you can move this around, and I probably should have just equaled these. All right. Come on. So you can drag these around, and wherever you want to put these lines, you can put fixed coupler positions. So let's just go here for now, and then we can draw our other ones. Draw our other ones if it lets us. And we want the angle between here to be 10 as well. And now it's 12. We don't want 12. We want, and I just type 12. Of course. All right, so we got 10 here. Let's also make these two equal. So I didn't lock it. See what happens when you don't lock it? I'm so eager to move to the next step, I'm forgetting stuff. All right. So now we can drag this around. And say let's be a little creative. Let's move our pivots from above. Actually, because this is just an example, I'm just going to be arbitrary about this. So Let's keep it kind of close because I'm lazy. All right, so these are our pivot lines. All right, so now we can get rid of some of the stuff. The pole, let's go ahead and hide this since it's not really in the way. All right, so the last step that we want to make is going to be our, what do you call it? The rest of our connecting links. All right, let me make sure. All right, next step is to select our connecting links. That's what I thought. I've done this a little bit nowadays. All right, so in selecting these, the way you can distinguish between your pivot lines is you always go follow the direction of rotation of your two positions. You always move from your moving pivot to your fixed pivot. So the fixed pivot is going to be on the right side in this scenario. If the rotation was in the other direction, the moving pivot would be on the right and the fixed pivot line would be on the left. So that's just something you want to remember. So in this line and this line, they're going to be our moving pivots, and our fixed pivots are going to be on the inside. So just for shits and giggles, let's draw these links like that. So this is an arbitrary example, so there's no things. Now our fixed pivots are going to be here. Our moving pivots are going to be here, which this requires an additional extension to our mechanism. So let's draw. Let's go ahead and save that. So now we have our connectors. I'm going to go ahead and hide the pivot lines just to clean up our thing a little bit. And we're going to call these connectors. I know you guys are probably seeing my autocomplete up here, but Creo is finicky when I use my autocomplete and it doesn't complete the word like it should. So those of you screaming through the screen right now to tell me a shortcut doesn't work. All right, so lastly, let's do one more sketch just to get our mechanism, which is going to be something neat. I'm going to show you guys in a second. So front sketch. Actually, no, let's just skip it. I changed my mind. So let's go back to the main assembly. So now we want to draw our coupler, or we want to create our coupler. I haven't done this beforehand, probably should have to save time, but screw it, who cares? So let's create a part. By the way, you can create parts in assemblies. You don't have to create them outside like a new part. So we want to create a part. Let's call this coupler. Now, most of the time, you already have a coupler designed. Like, for instance, like the grip arm to a robot is a very common 4-bar linkage device. And all right, so for now, it doesn't really matter where we place this, but I'm just going to place it default, which just sets it on the origin of the assembly. And then we want to activate this guy, because now we're going to use the background references that we've developed in these sketches to draw our coupler. So our first part is going to be, first thing to do is just going to be extrude out of the plane. So we'll go into our sketch, and now we know we need to draw a coupler that links these things together. So I like some round things, so let's make these all the same diameter. Let's do 3/8 of an inch because it's a nice number. You'll notice I am very OCD when it comes to this stuff. All right, so now we don't need center lines. Now we need to connect these. And a cool feature I recently learned about is this tangent line option. You can literally draw tangent lines to a circle. How neat is that? No more trying to figure it out. So now we can trim the unnecessary components. We don't need the circle. We don't need that part. And of course, I got rid of that line. It's another thing you guys have advantages over me is I literally have to pause my mouse in order to click. All right. And of course, there's something more. There's always one straggling line. That's what happens when you do around references. Work? Look at that. Beautiful. All right, so now we have that. Now we can extrude it. Let's make it a 1/4 inch thick. Again, this is just an arbitrary thing. And let's center it. Oh, I forgot one thing. You're not going to want to forget this step because otherwise you're going to have trouble assembling. You need bolt holes. And of course, the last one didn't match the size. So common screw size is 1/8 of an inch. So let's make this a little larger. And we're extruding by 0.25 and we're splitting it. So now if you look, it goes straight to the things. So there's another thing we want to do. So let's go ahead and create some axes in our part. So this is going to be a moving pivot. So I'm just going to call it moving pivot 1, or you can do moving pivot left, depending on how you want to do it. And of course, this little thing blocks my hole. Let's do moving pivot 2. Beautiful. So now we have a part that goes to this thing. And now, if you remember, let's go back to the assembly. I rigidly affixed it to the assembly. So I'm going to go back into this. We're going to delete this connection because it's in our way. So let's just get this out of the way for now. So we can ignore that for now. So now what we want to do is create our connectors. So we're gonna do this a little bit differently. Instead of drawing designing the part like we just did, let's go into our connectors. Because the connecting links, they're usually like just straight up linkages. They don't have any complex geometry or anything. So all I'm curious about is the length of these connectors. So if we know the length of the connectors, the rest of it is easy. You can just adjust the length because they're going to be the same geometry. So we want to know the length of this guy. Uh, 155. What about our other one? .93. All right. All right, so let's create a connector. It'd be so nice if I can use this autocomplete, to be honest. All right, so we're creating a connector. My windows keep getting in the way of them. I'm not even going to worry about assembling it yet. And this kind of get a little messy, so I'm just going to open this up into a new window. All right, so the first thing I'm going to do is sketch. There's a reason why I want to do sketch, and of course it's going to be a pain in the ass. And do that, so front, sketch. Let's go to line. We're still on tangent line. Let's go to fixed line. All right, and it was what, 1.55, not 207. All right, so this is going to be like, again, like a skeleton model in the assembly. This is going to be like the skeleton for your part, for this link, and I'm going to show you why. So now that we have this, I'm going to go ahead and create axes for assembling. Because you'll see, I want to get rid of my planes, they're in my way. All right, so these are going to be pivots. So I want them to go normal to the plane. All right, so one side is going to be a fixed pivot, so FP. And the other one is going to be a moving pivot. Now, you don't have to draw all of these datum planes to do your assemblies. You don't have to name them. But when you start creating really complex assemblies, it becomes very nice and handy if you could just look over here to the model tree instead of trying to like select the line in your assembly, where you can just click these. And I'll show you when we get to assembling how this is going to be very easy. So now that we have our axes that the pivots are going to go through and our skeleton, we can go into this, not a sketch, wrong button. We can go ahead and extrude off of the front datum plane. So in our sketch model, so we drew those axes. So we want to now we want to use these axes as our references for this. You'll see why in a minute. So let's stick with the same. It didn't select. All right, cool, we're good. I wanted to avoid selecting the actual sketch. So let's go 0.375 again, just to keep the same. Wow, it looks a lot bigger now. That's smaller. That's what she said. Ignore me. Why are the windows always supersized? All right. Tangent line again. Obviously, you don't need to do this tangent line to connect these, but there's another reason why I do this. Delete these to make our thing. And then we have our little rotation, our bolt holes that we're going to keep at 0.14 inches again. All right. So let's do 0.25. Technically, I'd do another step in this, but just doing that. You know what? I want to do it. I'm here anyway. All right. So why is this longer? Because we're going to cut out something on the inside. So let's do a top sketch now, or a top extrude to remove material. All right, so we're going to go to these references again. We're going to select these two, get rid of these two. Oh, that's right. That's not enough. All right, no, so we need to select the front. All right. I always forget that it doesn't go back to that. All right. John, what are you doing? You're drawing lines. All right. My favorite offset tool. Our coupler was 1/4 inch thick, so let's make this a 1/4 inch slot. Minus 0.125. All right. Obviously, if you don't want to watch this part of the video, you can just fast forward to where I actually get done assembling. Let's get rid of you. So, actually, if the whole part's 0.3875, so we need to offset. In order for the other part to be able to rotate freely in it, we need to do half of 3/8, so 3/16, which is 875. Same with this, 0.1875. All right, so now we can start trimming. So we know this line is not going to need to be here anymore. Or these, we don't need this middle stuff. So we're just essentially getting a slot for our coupler to freely rotate in. All right, so now these are all based off of the parts. I need to get rid of these. So all we want is these axes. We don't want the actual part to work. All right. So we're going to split the middle. Why isn't this work? Oh, we got to remove material. Duh, John. You got to do what you want to do. All right, so now you can see that the coupler should be able to freely rotate within this little slot. So this is a very simple part. very simple. But I went through numerous extra steps that are probably unnecessary. Why did I do that? So if I go into this, in that definition, the other length was what, 1.93? If I can aim my mouse correctly, 1.93. Guess what? The whole thing just lengthened to the desired length. So now what I can do is I can go back to my shorter length, go ahead and save this. This is probably a step in the very beginning I forgot to do, and I didn't save my assembly, so if I X out it right now, I'd have to do everything all over again. So while I remember that, let's save this assembly. Oh, of course. Regenerate. All right, so we're saved. All right, so we're at the part. So now this is connector 1, and so an easy thing, instead of redoing all this, we can go to Model, Save As, and we could do connector 2. On-screen keyboards are great sometimes, but sometimes they get phantom effects. It literally thought my keyboard was still over there, and now it thinks it's in the middle. Another thing I have to fix. All right, so this is still connector 1, so we can go out of that. So let's go ahead and assemble connector 2 just to bring it in. And now in connector 2, we can go straight to the sketch and edit the sketch to be 1.93. And now we have our 2 links and our 2 connectors. So now one thing I did skip over that I usually do before drawing my parts is go back to the skeleton. Now that we have our connectors, we can actually draw our fixed pivot axes. And we want these to be normal to the front axis, front plane, not axis, John. So this is fixed pivot 1. Control front. This is going to be fixed pivot 2. All right. So now that we have all the references that we're going to need. Now notice I haven't drawn a base plate foundation because those are just static components to your mechanism. In a future example, when I actually do a real example, I'm going to do a robotic gripping arm for the end of a robot arm to be able to pick things up. I'm going to design it using a 4-bar linkage. I will, in that example, have everything needed, and it'll be a real-world example. But this is just to get the concepts of the rotation, angles, and poles to you guys. All right, so now we can start assembling. So the coupler, since that's going to be the last thing to assemble, let's reorder these. All right, so let's connect this one first. So we want to modify its connection. And now that we have these nice little things, instead of zooming in to look for the axes, to click on the axes, fixed pivot is going to go to fixed pivot 1. We're going to make that coincident. We're going to make this a pin connection so it can freely rotate. And then all you got to do is the horizontal placement. So you do front on front. And now it's placed. And now it can freely rotate around this thing. Look at that. Next, we're going to do the second connection. Same thing. So we're going to do fixed pivot to fixed pivot 2. We're going to make it coincident. We're going to make it a pin connection as well. And then the same thing with the front datum planes. Make them coincident. So now, if you want to drag these, they move freely. So now, lastly, we get to assemble our coupler, or connect the coupler to the connectors. So this is a little tricky if you've never done this, a dual pin connection. The first time I did this, it was like revolutionizing my way of life. But the first thing we're going to do is connect these pivot lines. So this is going to be a moving pivot on the link to the moving pivot 1 on the coupler. So let's do look at the coupler first. So we want moving pivot 1, and then we want to go to connector 1 and click on its moving pivot. We no longer need the skeleton. So now that we have that connection, we're going to make it a pin. And so now it needs this horizontal thing. So now this is a trick. This is a key important step. The horizontal placement of this coupler needs to be referenced to the part it's connecting to. Now you can align it using the overall assembly datum planes, but it will not allow it to freely rotate because it will be fixed to a non-moving object. So we want the front datum plane of our coupler to be coincident with the front datum plane of our connector. And now it says connection complete, which it is. So now these two pieces are connected, but we still have one more piece to connect. So we want to do a new set of connections. Turns it purple again. And now we want to open up connector 2. We want moving pivot 2 to go to moving pivot. And the same thing with the datum planes for the two pieces. So now it connects them together. And we have a complete connection. And there's always a circular reference in here, which is just lovely, and I need to figure it out before this part moves. Actually, it still moves. All right, so I won't be able to save it for a second, but when you do a bunch of references to other parts, they can kind of get circular. So actually, I think I know what that is. So let's do this. Let's do this. Let's go into this part. Yep, I figured it was that. Let's delete all of these curves because this part is trying to reference the skeleton, and it's a circular reference, as you can see. It's referencing the skeleton to be connected to the skeleton. So let's just do our front and top, or right and top. Boom. That should work. Let's connect this to the assembly. Let's refresh the model. And now if we make this, so you can see the edges, let's make this guy transparent so you can see through it. And now you can see that it moves from position 1 to position 2. It also can do a bunch of other things, and then I kind of messed it up already. But normally, this is how this Zimmerman's planar linkage synthesis using rotation angles and poles is accomplished. So you can go a step further and constrain these so they only rotate a fixed amount of degrees so you don't get stuck in this crazy rotation. But this isn't a real example, so I won't worry about that. Let's go ahead and hide the skeleton model. And now you have your part. So now that it's refreshed, we could save it. And that kind of concludes what we're doing here. So this is very similar to this example here, where you had to draw these extra connectors to your coupler. But you could avoid the extra linkage just by doing this. I will be doing another video just to show another feature. The one thing I didn't mention is that these pivot lines, they extend in both directions. So they can extend above your part, below your part. So these are infinitely spanned lines. As long as the two are separated by half the rotation angle, they will work. When we move into 3-position coupler example later on next week, it'll be a little bit more complicated. You have less freedom, but overall the same process is kind of the same. My next example would be just another alteration of this. I won't be drawing these extra links. I'm going to draw the fixed pivot lines directly to the coupler, or the moving pivot lines directly to the coupler, so that you'll have an example like this. And I'm also going to, in that example, go over the feature of how the lines can extend infinitely. After that, my next plan is to do the gripper arm handle, so I can, for a robotic arm. So it's an actual application of this method, so you can actually see how it would work in a real example. But that's it for now. I guess comment below for any suggestions you have for me for how these recordings. This is the first recording I've ever done. So any helpful advice from you would be appreciated. But that, have a good day, and I'll see you guys later.